welcome to this session. This is my first time actually doing this, so there will be a lot of demos and a lot of ways this can go wrong. So, finger crossed. When Brian invited me actually to come to the conference, I told Brian I'm not a Java developer, so I don't know what I'm going to be standing in front of a bunch of Java developers and telling them about. And he's like, yeah, do something about Cube. And I'm like, well, I can show them how I write apps for Cube. And he was like, that works. So the aim of this session really is to show you what I think a developer setup for somebody who writes application for Kubernetes should look like or could look like. There are tons of tools. There are hundreds and hundreds of open source projects. These are the projects I use, right? This is by no means the ultimate way to do it. This is my way, right? And pretty much all the tools I'm going to be talking about today are programming language agnostic. They're not, like you can write apps in Java or Node or whatever. I write Go apps. So I mostly use this stuff, but I have tested some stuff with Java and it works. When I have like a demo app, I can just fire up the same setup and build my apps and it just works. My name is Abdel. I'm a cloud developer advocate at Google. I'm actually based out of Stockholm. And I've been at the company for almost 10 years. I co-host a podcast called Kubernetes Podcast by Google, and I mostly work on Kubernetes-related topics, service mesh very recently, and a little bit of security. And so what we're going to be talking about today, or we're going to be covering, are three main things, right? As a developer, these, I think, are the three main things you care about. Where to run your apps, or which flavor of Kubernetes to use, remote versus local, combination of both. How do you actually run and deploy these apps? So how do you package them? How do you run them? And when you are doing your development cycle, how do you run apps, modify them, and see your changes? And then how do you connect to remote apps? This is crucially important when you are working on a microservices type environment where you have maybe a remote system, a remote development environment that has multiple microservices, and you're trying to change one of them, right? And we're going to see like one particular tool that is very useful in this context, which allows you to essentially put your workstation and make it look like it's part of the Kubernetes cluster. It's like your development environment is inside the cluster. So you can actually talk to everything inside the cluster, and you can change apps, and you don't have to expose anything to the internet and that stuff. Starting where to run your app, right? So basically you have kind of 4 main options, local or remote. So running locally, you can go pretty much fully offline. And this is what I'm going to show with a couple of tools. You can basically just write apps offline. It's not going to be 100% offline, because if you're writing apps that have requirements, that have dependencies, like Maven or whatever node, you still need the internet to download these dependencies. But you can have your development cycle, your registry where you put your containers, and your development environment, and where you're running your app, running completely on your local computer. Typical thing that people do is dev for local, and then remotely for anything QA and stage and everything like that. Or you can also work purely online, which you just need access to the internet, and then you can do whatever. I'm going to use actually our version of Kubernetes for some of the demos, but it doesn't really matter which version you use. Let's start with very simple stuff, right? So how many of you are familiar with Minikube? Okay, so how many of you use Minikube? All right, good. Minikube is pretty cool. I like it, but it has a problem. It's a pain in the butt. When it started initially, it only supported KVM and VirtualBox, and I don't know about you, but I really don't like VirtualBox. It started supporting Docker very recently, so you can actually run Minikube with the driver Docker, and it will start a Docker container with your cluster inside. The issue with Minikube is that most of the time, it's very actually hard to start a multi-node cluster. So if you need multiple nodes, it's kind of complex with Minikube. What I prefer personally is you could also use kind Kubernetes in Docker. It's also the same concept as Minikube. It runs the Kubernetes cluster inside a Docker container. My preferred way is K3D, which is a project by Rancher. So K3D is a Kubernetes distribution by Rancher, and then they have a lightweight version of that which can use locally for development called, no, the other way around. K3S is the distribution, and K3D is a local environment. And so with K3D, you can simply write a config file that looks like this. You can, not this one. Let's start with this one. So it's just a YAML file, simple configuration, and I can define how many servers and how many agents. In Rancher terminology, servers are the API server, so the actual control plane, and agents are the worker nodes, right? So here I want to start a 3 nodes cluster, right? And what's also cool about it, which is what I like, is you can create also like a local registry. So I'm just gonna fire up the K3D command line. So K3D cluster create, I pass the config file, and then I say create a registry for me, and then I give it an URL. So the registry URL is gonna be my cluster-registry, and it will map to 0.0.0.0 on port 5432. So this will start 3, 4, 5 actually containers. So 1 container will have the API server, 2 containers will have the agents, 1 container will be the registry, and then it starts a proxy container to act as a load balancer. So if you need to deploy an ingress or like an actual HTTP load balancer, you can, and we're gonna see that later. So it will fire up things. Meanwhile, what I have done, I have cheated a little bit, and I changed my etc hosts to just points. So when you create a registry like this, K3D will prefix it with K3D dash. So I created a little host in my hosts, K3D dash my cluster dash registry.localhost maps to localhost, right? So hopefully this is done, good. It's actually pretty fast, it's one of the reasons I like it. So if I do my Docker images, I can see that I have all these, of course I close the terminal. No, I just don't want this one, don't want this one, I just want 1 terminal. Yeah, that's what I'm looking for. All right. Apparently I have a lot of apps running in here. Let's see, where are the ones we care about? K3s. Actually, it's one of the reasons I don't like doing demos with the terminal is that visibility is not great. So that's what I do, is I usually go with, what is the Docker? So I like this Docker plugin in Visual Code because it's better in my opinion. So I can see here that I have basically 3 images that are, or 4 or 5 images that are tagged Rancher. 1, 2, so the ones that says version 1.26, those are the Kubernetes nodes, those are the Kubernetes images. So this is starting 1.6 by default. I have one here that says registry, so that's the container registry. And I have one that says K3D proxy, that's Nginx. So if I want to like push apps toward the local registry, I can simply do something like Docker images. I guess I have like an Nginx image here or something. Yeah, I can do Docker images, Docker, tag this one, and then I can tag it with K3D dash my cluster registry .localhost on port 5432. And then call it Nginx, and then I can just do a Docker push to that container registry. Miss something? Docker push, Docker push. And then I need the URL, obviously. So this is gonna push it to the container registry, which is the one that was fired up by K3D. I don't know about you, using Docker to talk to multiple container registries is a little bit not very nice from a user perspective, from a user experience. Luckily, the Docker plugin in Visual Code has this way where you can connect to like a remote registry. So you can just say, I want to connect to a remote container registry, the URL, no username, and then I have my container registries here, and I can see that I have my Nginx image running there, right? So now I have a container registry which runs locally, and I have a cluster which has 3 nodes which runs locally. K3D, the command line, already pulled the context, so kubectl is already configured for me. So if I do, are you familiar with kubectx? Which is, so kubectx is, oh, okay. So kubectx is a command, so, okay, let's go one step at a time. You know when you have kubectl and you configure kubectl to talk to multiple clusters, if you want to change context, how do you do it? Kubectl context, list, contexts, or something like that, I guess. Let's see, I haven't used it for a while. Config, thank you. Get context, are you sure? All right. All right, cool. So that's, and then if I want to switch context, I have to do config set context, I guess, right? That's, or use context. OK, so that's bullshit. kubectx. kubectx is a single command line. It's under the kubectl plugin managed through Crew, so you can just use kubectl to install kubectx. And I can just run kubectx, and it tells me to two contexts I have. I can do kubectx and switch to the other one. Here is my favorite part. If I want to switch back, I just do kubectx dash, and it will switch back to the previously used context. Right? There is also something called, I don't know if you know it, cube. I don't remember if I have it. There is also a command line called kubeNS, kube namespace, and it does the same thing for namespaces. So if you have to interact with different namespaces, you can do kubeNS, the namespace you want to talk to, and then you can just set the namespace, and then you don't have to do the dash n each time you're running the kubectl command line, right? All right, so that's already a win. I cheated you something. Good. So I am already pointing, I think, to the context I want, which is my local cluster. So if I do kubectl get nodes, I can see that I have a 3 nodes cluster, right? I have a control plane, and I have to work with nodes, and it's based on version 1.26. Now, if I want to deploy to this thing, by the way, also, one nice thing I like about K3D is that if you want to add nodes to the cluster, you don't have to recreate it. You can just run a command to just add a node. So I can do this here. Let me just make sure that I'm talking to the right K3D cluster list. Yep, so I can just do something like K3D node create blah blah role agent, and then the cluster I want to add it to, and then just will fire up new container and then add that node to the existing cluster. So this should not take too much time, and hopefully it will just work. Yeah. So now if I do kubectl get nodes, then I have a third node, right? Cool. So now I have a little demo app here, which has it's basically like a 2 tiers app, like a web application and the backend, and each has its own Docker file, and it has its Kubernetes cluster files and all that jazz. If you don't want to bother too much with deploying stuff, you can use something called Skaffold. So Skaffold is a command line tool that allows you to configure your applications through a single YAML file. And you can say, I have multiple microservices, and then you can define how each microservice can be configured, can be deployed, and how each microservice, where each microservice is built from. So here I have a config that defines 2 artifacts. One is called Leroy Web, and one is called Leroy App. Both require the base, so the base is just a base image. The manifests are in each folder under the Kubernetes folder, under the Kubernetes folder. And so the context here, Leroy Web, is the name of the folder. So for the artifact called Leroy Web, the code itself is inside the folder called Leroy Web. And for Leroy App, the code is inside Leroy App. And then I can also define some port forwarding. So then I can tell the Skaffold, once you fire up the services, you forward the ports 8080 to 9000 and whatever that other port to 9001. And so if I want normally to just deploy this app using kubectl, then I have to go to the first folder, go to Kubernetes, deploy this one, go to the second folder, go to Kubernetes, deploy this one. I don't want to do that, so I just do Skaffold dev. That's it. So this will fire up Skaffold. It will read the YAML file. It will build actually the container for every image. And actually, I made a mistake, so I'm going to stop it for a second. So by the way, if you just fire up Skaffold dev, it will default to Docker Hub, to the local Docker registry, right? But in my case, I wanted to use my, of course it will fail. I wanted to point to my Docker registry that I created with K3D. So I can do that by using this command. So Skaffold dev, and then I can define a default repo. You can also do Skaffold config set and define the repo. So then it will find the images. What's nice about it is that it will also tag them. So it will generate random tags. And each time you're changing the app in the container, it will just regenerate a new tag. So you don't have to worry too much about tags. And we know that developers, we don't like to tag stuff. Because if it's up to me, I would just always tag things latest, because that's technically the latest thing I built. So it's pushing the images. And I can already also remember that plugin in Visual Code I told you about. It has a nice, where are the clusters? So these are the registries. So if I go here, by the way, If I refresh my remote cluster, it's already pushed the images, right, in my remote cluster. But then it has, I'm not able to find in my, those are the containers, but it has a thing where it can show you your remote Kubernetes clusters. Okay, never mind. There is another plugin called Cloud Code. This is our own plugin that we have built. And it has a tab called Kubernetes cluster, so it detects actually your local contexts, and then it shows you all your Kubernetes clusters in one session. So here I have my K3D local cluster, and I can look at the namespaces and look inside the defaults, and I can look inside the deployment, and I see the two deployments, right? Okay, so my scaffold is running, and Visual Code have already put in place some really nice, handy-dandy port forwarded rules for me. So I can already just go here and do localhost 9001. And I'm talking to my app, which runs locally, right? Now, if I want to, if I'm doing active development, which I guess most of you do most of the time, I can go to my web app, and I can go to here, this one, and I can remove this to hello. I don't want to write the wrong thing, so you guide me. You tricked. Is this how you write it? Yes? Okay. Then thank you. Because like a few months back, I was in Finland, up in Tampere, a city, and I was doing a demo, and I wrote it wrong, and somebody pointed out, which is extremely unFinnish, because Finnish people would not talk to you at all. So because I'm running Skaffold in dev mode, once I changed my code and I saved it, then Skaffold will pick up these changes and will rebuild the container, and it only rebuilds the container of the application that changed. It doesn't rebuild everything else, right? So it will rebuild it. It's going to take a little bit of time. So we can already move on to the next thing, and I'll come back to it and check it. Eventually, at some point, if I refresh this, I should say, hello, you tricked. Now, one thing you as a developer doing apps for Kubernetes you're probably faced with is Kubernetes changes APIs between versions, right? And sometimes you're using one version of some app API, and then you deploy your app to a new API or a new version of Kubernetes, and things go wrong. And you want to be able to catch those before your boss does. So K3D has a very handy way for creating clusters based on different versions of Kubernetes. And the way you would do that is with your K3D file, you can specify an image. So the last version of Kubernetes that is available right now is 1.27. The one I was deploying previously is 1.26. So I just I uncommented the image, and I just specified which image I want. Those images are available in the Docker Hub of Rancher, so you can find the exact URL for the image in the Docker Hub of Rancher. It takes Rancher about a month between Kubernetes new version is available and them making versions of it available in K3D. But once they're available, then you can just specify an image, and then you can fire up a new cluster. So same thing. Create using the config, and then I'm creating also a new registry. And this should just work, hopefully. So let's go back and check that scaffold thing I've been doing. Yeah, so we just rebuild the app, and then redeploy the image, and then I can... So basically, your development cycle could be change files, save, wait a little bit, grab a coffee, watch YouTube, and then stuff happens, right? I mean, let's face it, you watch YouTube between compilation, right? Right? OK. So this will fire up a new cluster, 3 nodes, 1 API server, 2 worker nodes, a new registry. And what I can do, which I'm going to show you in a bit, is hopefully wasn't finished. OK, so I have a new context, which was created by K3D, right? So if I go and do kubectl get nodes, then my new cluster is based on version 1.27, right? Now, the same app that I deployed earlier, right? I want to test it on the new version of Kubernetes. So all I have to do is just stop scaffold dev, make sure I'm pointing to the right context, and then just fire up scaffold dev again. So scaffold by default will point to the currently selected context. You could also, Skaffold has a flag which is dash dash. No, okay, so I have to go inside the Leroy folder, and then I can just start a new dev cycle using the new repository, and this will rebuild the images, push them to the new repository, and then give me, again, port forward, then I can check my app and see if it works. I can also just go back here to that Docker plugin thingy, and then I can configure the new registry. Correct. New registry. Localhost, boom. No username. Boom, I can visualize both my registries, and hopefully at some point, stuff will start happening eventually here at some point. Come on. Don't do this to me. Eventually, whatever. So you get the point. I have fired up a new version of Kubernetes, redeployed the same app to the new version of Kubernetes. So this would allow me, if I'm a developer and I want to make sure that the APIs haven't changed between versions, I can easily redeploy my app to a new cluster and then make sure they work. Now, what if you don't like Docker and you don't like Kubernetes, and certainly, and most crucially, you don't like your writing YAML files, right? Because everybody likes YAML files, right? Right, okay, good. So before I move there, actually, 1 second, I want to show you how ingress works. Like, have you used ingress API in Kubernetes before to deploy load balancers and all that jazz, right? Okay, cool. I'll explain it in a moment. Just give me a second. Sorry, kubectx. I'll just switch back to this cluster. Hopefully it works, because I did a little mistake, which is I pruned the network. Okay, it's still working. All right, cool. So let's do something. I can actually create, if you need to be able to deploy an ingress object, which is essentially ingress in Kubernetes is just an object that defines a load balancer and allows you to define a set of rules to say, if I'm talking to this host / this path, then I go to this backend. If I'm talking to this other host / this other path, I go to this backend, right? What you can do with K3D is you can make sure to expose the load balancer, which is, remember I told you when you deploy K3D, it will deploy a container which acts as a load balancer. So you can expose that load balancer on port 80. So you can expose it outside the cluster. So this will fire up a new cluster, the same exact thing, 2 nodes, 1 control plane, and then it will give me port 80 listening on the load balancer. So I can deploy to it whatever I want to deploy, and just deploy an ingress object and then use it to test my ingress configuration. It uses traffic, if you are curious. It uses traffic as an ingress controller, but all ingress definitions are equal. Each kind of ingress controller has its own little tweaks for doing certain things, but they all work the same way, more or less. So what I have here is I have 2 apps. They're exactly the same app, but just deployed twice. Not this one, this one. So I have, let me close all of this stuff. Close all, reopen this one. So I have just 2 deployments, one called foo with a service called foo, and one called bar with a service called bar, right? So I have deployed a new cluster. So just go ahead and let's make sure I'm pointing to the right cluster. Cool, so then I go ahead and do apply kubectl apply -f ingress amp.yaml. So this will deploy 2 pods and 2 services. Kubectl get pods. Okay, they are gonna be up and running eventually at some point. I have anxiety, so I will do a watch and just wait for it. And then I have an ingress object here. If you have never used ingress objects, this is how it looks like. It's just an ingress object. It has a name. It has a host. The host is optional. You don't have to do it, but I want to do it because typically that's how you expose your applications to the internet. You have a single domain, and then you use path to forward to different backends. And then I have one path that says foo forward to the backend called foo, and /bar forward the backend called /bar, right? Pretty straightforward. So I will go ahead and deploy this one. My pods are ready, so I'll go ahead and deploy it. I think it's called ingress. Good. Now if I do a kubectl get ingress, I have an ingress running. It's using traffic as a class, and it has an IP address. So I can take any of these IP addresses. So all of these IP addresses are exposed locally on port 80. So if I talk to any of them on port 80, it should work. But because my ingress defines a host, I cannot just curl the IP address. I need to curl it and send a header, which is the right host, right? So if I go here, and because I'm lazy, I already wrote these command lines. So if I do a curl, pass in a header which has host called jspring.io, which is the host I defined. It should be .nl, by the way. I screwed that one up. And then the IP address /foo. Then I should be forwarded to the backend called foo. By the way, this app I used called Where Am I? When you talk to it, it just returns a JSON, which has some data, and one of them is the pod name. So just from the pod name, you can conclude which pod is answering us. So this is returning from pod foo, right? And if I do bar, it's returning from pod bar, right? Pretty straightforward. I didn't have to do anything extra. I just deployed the standard ingress. So the same exact object, I can deploy it to my AWS or my Azure or my Google Kubernetes, and it will just work. Make sense? All right, so let's go ahead and go back to the initial point of what if I do not want to write YAML files and all that jazz. I don't care too much. If you don't like writing Docker files or writing YAML files or Helm charts, and which no one likes, or any of that stuff, there are actually a couple of ways you can go about it. I think for you as a Java developer, you would tell me Jib or Buildpacks. I think you're familiar with Jib, probably, GIB, or Buildpacks. Yeah? So these Jib or Buildpacks are two tools that you can use to actually build apps without writing a Docker file. So they have like images that have an analyzer that analyzes the code source and figure out what's the entry point and what programming language, and then it kind of builds a hidden Docker file and then builds the container image from that Docker file. Those tools are great. Or Jib works with Maven. It's a plugin in Maven, so you can just add it to your pom.xml file. And I'm talking like I know what I'm talking about. I have no freaking idea what pom.xml is. I just know that that's how it works. You just add the plugin, and then you do a Maven build, and then you give it a target, and then it builds your container image. Those tools are great. The problem that I have with them is that if you don't have a Docker file, then you don't know how your final image was built from, right? Which is kind of the purpose of these tools. But then if you need to tweak the final container image, then you don't have a Docker file to change, right? Because the whole point is that they don't need a Docker file. And the second thing also is if you need to tweak the app itself, then you don't have a manifest. You don't have a YAML file that if you need to just do some changes. So I found this tool. It's kind of under the radar, and no one really talks about it that much. I don't know if you know about it. It's called Draft. It was written by Azure. It's open source by somebody used this before? Just one person. OK. So what it does, essentially, I have this file here. I'm just going to remove my manifests, because I was testing before. Remove my Docker file, and then I remove my Skaffold file. So right, I have just main.go and readme, just an app. I can do a draft create, and it has this handy-dandy kind of questionnaire. It looks like ChatGPT asking you stuff. So it says, I detected Go. Is this Go? Yes. Which port do you want to expose the app on? I can say I want on 8080. Which version of Go do you want? So I can do 1.18. It's not going to work because I have to go to Docker and fetch the actual image tag, but let's just say this. Or maybe it's just to make sure it can do latest. Do you want to generate Helm? Do you want to generate customize? Or do you want to generate manifests, right? It have all the options. So I'm just going to generate manifests. Expose this on port 8080 as well. The name of the app, hello app. Please enter the port of the service, 8080. Namespace defaults. Name of the image, hello app. Name of the deployment, latest. That's it. So what it did, it created two things for me. A Docker file. Now, granted, this is not the best Docker file around because it doesn't use multi-stage build. But at least I have a structure, so I don't have to start from scratch, right? I can take this as a base and just add stuff to it. So that's the first thing. And then it created manifests, which basically is one deployment file, which looks legit to me from the years of writing this stuff, and services, right? And the defaults to load balancer, there is a way for you to change which service you want to expose. Now, if I really still don't really like to write YAML file, so you remember Skaffold, the tool I told you about earlier? If I don't want to start from scratch, it also has an init feature. I can just do Skaffold init, and it will read the local files, detect what's going on, and it will generate a scaffold file for me. It tells me, does this scaffold file look good? I have one artifact. It's called hello app. It uses a Docker file, which was built by Draft. And these are the manifests, right? Yes. Sounds good to me. All right, so I have scaffold. So now, this is... It's good, right? I have my scaffold file there, right? OK, good. So now, if everything goes right, I should be able to do scaffold dev. And this is where I'm crossing my fingers, because I'm not sure if it will work. So it should work the same way. Just detect the YAML file, detect the manifests, build the container image, and just deploy it for you. But at least compared to using something like Jib or Buildpacks or whatever, I have a Docker file. I have something I can use. I don't have to write it from scratch. I don't have to worry too much about it. But in case I need to change it, it's there, right? Compared to some magical things that builds a Docker container for me without me knowing what's going on behind the scene. And this is by no means the only tool. There are like thousands of tools that can do the same thing. This is just what I use, again. I am going to save myself the embarrassment of potentially this not working and just move on to the next thing, because I'm not sure if this will work. I was not quite sure about it. Let's see. OK. I'll go back to my slides really quickly. So the last thing I want to talk about, so we talked about Skaffold. The last thing I want to talk about is this tool called telepresence. It's pretty cool. Have anybody used telepresence before? 2 people. All right. So there is one person who raised their hand, and there is one person who pointed to their colleague. It was like, this crazy guy. So tell me if you can relate to what I'm about to say. You have a bunch of microservices running on Kubernetes installation. They are running remotely. You want to change one of them, right? And that one particular microservice that you want to change is not the one reaching out to other apps. It's actually being reached out by other microservices. In other terms, it's a service that receives requests, doesn't send them, right? If you take that service and you change its code, in order for it to work, you have to push it to the Kubernetes cluster, because it has to be inside the cluster so that other microservices can talk to it, right? Make sense? Now, what if I want to run it locally, develop it locally, change it locally, and then have my cluster, my other microservices, which are remote, talk to it? Right? Not the other way around. Not me writing a microservice which makes requests to a remote microservice so I can run my microservice locally, and then I can do something like kubectl port forward to the remote one, and then I can make them talk to each other. The other way around. So telepresence, what it does essentially, it connects to a remote server. It creates a bidirectional tunnel, secure tunnel. It's SSL-based. It runs like a little daemon set locally, and it runs a local DNS resolver. And basically, what you can do is you can either write apps locally and make them resolved through the DNS to the remote apps. I'm going to show you how that works. Or, which is the cool thing about it, is that you can change your apps locally and have apps in the remote cluster reach to the local version that you are running. So let me show you how that works. I know that it's not clear like this when I just described it. And of course, my build failed. But that's fine. Let's move on. So let's go to telepresence. So I have a remote cluster. So this cosine cluster is remote. It's running on Google Cloud. It has a bunch of pods running in it. So all these are like an app that I just downloaded and deployed. You know, just a random app I downloaded from the internet. So once you have your app, what you can do is, the first thing is you do a telepresence connect, and that will basically connect to the API server, and then start that small DNS server locally. You know when you are on Kubernetes, and you want to make services talk to each other, let's, for example, make, I don't know, randomly, I want the product page to be able to talk to the details, I can use the Kubernetes built-in DNS system, right? So the way I would resolve details from product page is I would just talk to details.default, which is the namespace where all of this is deployed, .svc.cluster.local, the local default service discovery in Kubernetes. And I'm seeing a lot of faces looking at me like, what are you talking about? Does it make sense what I'm saying? Right? OK, good. So what if I can do something like this? It's not going to work because I'm not sending the right request, but I have something answering me. So I'm actually using telepresence, and telepresence creates just small, like it creates DNS entries in my laptop. This is my development environment. And through these DNS entries, I can reach to all these remote services in my Kubernetes cluster through a tunnel. So I don't have to expose anything to the internet. Does this make sense? So if I am, for example, doing developments on the products page, if I'm changing the products page, and the products page is configured to call the details microservice using details.default.svc.cluster.local port 8090, then I don't have to do any changes. I just need to run the local version of the products page, and through telepresence, it's able to resolve all the dependencies like if they are running in the same cluster. So essentially what telepresence does is it makes my development workstation part of the network of the cluster itself. Make sense? All right. Now, what if I want to do it the other way around, right? So let me do something first. So I'm going to deploy that. So yeah, kubectl apply -f deployments. So it's that, you remember that app that returns like a JSON file or JSON output that tells you where it runs and which pod it is? I just deployed it here, not this one. It's the same as the Where Am I app listening on port 8080. So it's running remotely. So it's running remotely, and it has a service that exposes it. And then I created also an ingress for it. No. So I created an ingress called Where Am I? Let me just bring this up 1 second. And this demo also, I'm not really sure if it will work, but let's see. So I have an ingress, so I have basically a load balancer pointing to a pod, right? So if I take this IP address and go to my browser, I should just get a JSON output. This is what I expect. This is what this app does. It tells you what's the name of the cluster, what instance it runs on, what's the name of the pod, et cetera, et cetera. Now, what I'm going to do, and this is really stupid, but just to like demonstrate the points, I'm going to run a local version of Nginx. So I'm just going to fire up Nginx on Docker, right? So this should just fire up. No. Port, okay. Okay. No. I could reuse it, but I don't want to. I want to start the whole thing from scratch. All right, cool. So I'm just going to run local Nginx because I want to see the logs. All right, so now I have Nginx running, right? So from my local development workstation, if I do localhost, yes, I should have Nginx replying to me, right? So what I'm going to do is I'm going to use telepresence, and telepresence has a function or a feature called intercept. So what I'm doing is I'm intercepting traffic going to the Where Am I app, which is remotely, right? And then I'm saying if traffic goes to port 8080, which is the remote port, that's what Where Am I listens on, I want to forward it to port 80 locally. And what do I have listening on port 80 locally? Nginx, right? So, boom. Hopefully this works. All right, so now, theoretically, if I go here and refresh, eventually I will have Nginx replying to me. But it's going to take some time because the way telepresence implements that is that it will take your existing container and it injects an agent into it. And then it will intercept traffic coming from wherever to port 8080 to that local pod, and then forward it through the agent to the local tunnel to my local computer, right? So that takes a little bit of time, and hopefully it worked earlier when I was in the speaker's room. So eventually it will work. But you get the point. The point here is that telepresence, because it has this feature of dual bidirectional tunnel, it's able to proxy traffic locally from your computer toward the remote cluster, but also proxy traffic from the remote cluster to local. So if I am running telepresence, I can intercept traffic going to a microservice and say, well, this traffic going to this microservice, now you route it locally. And then locally, I can just run my Docker run on my local version of the app that I'm developing actively, and then just change code and then I go and hit my API endpoint or whatever, and it will forward traffic to my local version instead of the version in the cluster. Make sense? All right, that's all I have for you. I hope this was useful. I think I am almost on time, and I'm open for questions.